What is MOS? In this presentation, we will discuss the value of observations and how they can be used to statistically correct model data in a process known as Model Output Statistics, or MOS. Direct measurements capture the effects of small-scale terrain, unique localized atmospheric conditions, and land use at the project site. They are the best way to determine wind resource characteristics at any particular location, but only for a particular period of time. Also, observations are often unavailable at the location of interest or are too short in duration for a robust site assessment. 3-Tier incorporates observational data into our assessments whenever quality site measurements are available. We do this for several reasons. First, it allows us to directly compare model output with observed values to show the skill of our technique. Second, quality measurements allow us to statistically correct raw model data so that our long-term assessments more accurately match observed values. 3-Tier uses statistical relationships between a short period of on-site observational data and a longer modeled reference time series to calculate wind resource variability outside of the observational period. Record extension is typically backward in time for historical context, but can also be driven forward into the future. 10-year records are standard in the industry, but 3-Tier recommends longer records of 20 to 50 years to reduce the risk associated with long-term climate variability patterns that impact wind energy production, such as ENSO or the El Niño Southern Oscillation. There are various sources of reference data that can be used to understand long-term wind variability and ultimately power availability at a site. Quality-controlled measured data offer perfect correlation with site conditions and are vital, but only in rare situations are these records long enough to be used for long-term energy modeling and financing. When you only have 6 to 24 months of data, it is also impossible to know whether your measurements were taken during a high, low, or average wind period. Third-party stations are often publicly available and have long 10 to 20-year measurement records, but introduce significant uncertainty. It is generally difficult to know the quality of the measurements. Observations are also typically not available at wind turbine hub heights, so data at different heights must be extrapolated using engineering techniques like measure, correlate, predict. It is also hard to know if your site and the third-party station are in the same wind regime, even when the two locations are in close proximity. For example, wind behavior will be very different at an airport measurement station located in a valley than at a windy ridge several miles away. Proprietary references, such as tall towers operated by private companies as well as government and academic groups, are typically better maintained and thus more reliable. They offer longer records than site measurements, but usually only 5 to 10 years at best. Synthetic reference data is developed using advanced numerical weather prediction models. This type of data can be simulated for any period of time up to 50 years, at any hub height and at any location worldwide. Within the industry, there are some concerns about using model data because it is not as well understood. However, 3-Tier studies have shown that this method is quite skillful. Both internal and independent studies have also shown that NWP models produce more accurate results than MCP, particularly when combined with on-site measurements. In this one example from Paxton, Massachusetts, the black line shows 3 years of monthly mean measurement data from 2003 to 2006. The blue line shows the raw model simulation at this location over a 13-year period from 1997 to 2009. As you can see, the raw model data follow the same pattern as the observations and explain 84% of the variance, i.e. they have a correlation squared value of 0.84. But the model data have a low bias. The orange line shows a long-term modeled record extension that has been statistically corrected using the observations. The MOS-corrected record shows significantly higher accuracy in estimating wind conditions and a substantially improved correlation squared value of 0.92. It is important to note that the three-tier MOS-corrected data do not match the observed data exactly. A perfect match would indicate that the model data have been overfit with the measurements. Since the goal of MOS correction is to provide the most accurate estimates of wind variability outside of the observational period, overfitting is counterproductive because it means the estimates outside of the observational period are actually less reliable. To sum up, here are the key takeaways. On-site observations are highly valuable in understanding localized conditions at a site, but are generally too short to be used to finance a project or predict energy output over the long term. However, they are invaluable in enhancing the accuracy of mesoscale model output. NWP data and observations are both useful when used alone, but by combining the two through MOS, the result is much more valuable than either data source on its own. In other words, the whole is much greater than the sum of its parts. Three tiers MOS technique helps you manage the risks of wind power availability and does not overfit the NWP model simulation with measurements. Our proprietary technique allows us to accurately model periods of up to 50 years, reducing the uncertainty of natural variances in seasonal wind conditions and the impact of long-term climate patterns and anomalies on wind power production. Thank you.